Okay, so can you hear me, Arindo? Hello, can you hear me, Arindo? Am I audible, everyone? Okay, so can you guys reply in the chat maybe if you don't want to speak? So today we'll start discussing questions about week 5 lectures. Dibalojan, can you hear me? So yeah, today we'll start discussing questions from week 5 lectures, and mainly we'll be solving question from sequence, and especially like properties of sequences, when a sequence converges, when a sequence diverges, and like some complicated questions that may be important in the from the perspective of uh, competitive exams. And after that we'll be solving some questions from series as well. Okay, so before that I'll write some properties, or you can say as facts or lemma, that may be useful in the due course. Okay, so the first fact, or I should say lemma, the first lemma is that every real sequence has a monotone subsequence. Okay, so this is called monotone subsequence theorem. Okay, so this is like if you take any sequence of real numbers, then it will always have a monotone subsequence. Okay, so I'll encourage you to see the proof in any standard textbook. It is available, but I don't think we have time to solve or to prove this lemma here, but I'm gonna state this as a fact that we'll be using throughout. Okay, so it says that every real sequence has a monotone subsequence. Okay, so this is the first lemma. So I'm just writing all this as a fact, that such that we can use it directly when such questions come, related questions comes. Okay, so another important theorem is called Bolzano-Weierstrass theorem. Okay, so it says that every bounded sequence has a convergent subsequence. Okay, so if you give me any real bounded sequence, then it will always have a convergent subsequence. So every real bounded sequence has a convergent subsequence. Okay, so this is the second facts. So now we'll go to some convergence criteria. Okay, so that I'll be writing here. So let it called Cauchy and contractive sequence. So as I also stated in the previous class, I'll request everyone to write with me or to interact with me, so that will be useful for you. Okay, so this is how we do this class. This is called a live class. So if you don't want to speak, that is also okay, you can just put in the chat. You don't have to speak always, but if you also answer like with me, then it will be beneficial for you. Okay, so do not hesitate to speak up, so this will boost your confidence as well as it will be useful for you. Okay, so this is like one time opportunity. I'll not be coming every week. I mean, in the sense that every week we'll have different topics, different assignments to cover, correct? So if I ask some questions, if you know something, you can always answer. It can be wrong, doesn't matter. It's a part of learning. Okay, so I hope everybody has got it. So now I'll define two sequence. This is called Cauchy sequence. Another is called contractive sequence. So contractive sequence is a special case of Cauchy sequence. That means every contractive sequence is Cauchy. Okay, so let me write it first. So somebody has written good afternoon. Yeah, it is good afternoon. Now it is evening here. So yeah, I'll say good evening. So Cauchy sequence. So a sequence is called Cauchy. So if for any epsilon greater than 0, there exists a natural number n naught such that for all n comma m greater equals to n naught, or this will imply an minus am is less than epsilon. Okay, so this is like more than the definition of convergent of a sequence. So I don't know if you guys have seen it. So probably you guys have seen it, the definition of convergence of a sequence. Parshuram, I do not know which pattern like they'll follow for the exam. I'm not sure, but I think it should be like it used to be MCQ based question, right? In the final exam, right? But I don't know if they have introduced subjective questions. But I mean, you can just give an email to the NPTEL team. Probably you guys have the email, right? So then you can just contact them. I really don't know what type of questions they will set, but probably MCQ should be always there, and then they'll ask some subjective as well. Probably, I'm not sure. Okay, thank you. So yeah, this is the definition of Cauchy sequence. Okay. The next definition is contractive sequence. So you guys can also try to write with me, so that will be useful for you. Okay, so a real sequence an is contractive if there exists q in 0, 1 such that this holds. Okay, and this should hold for each n greater equals to 1 or n greater equals to 2. So it's like the difference between the subsequent terms will be less equals to defined between the another subsequent term. So if you just put n equals to 2, it will be a2 minus a1 less equals to q times a1 minus a0. I mean, sorry, a3 minus a2 is less equals to q times a2 minus a1. Okay, so this is I don't know if you guys have seen the definition of Lipschitz continuity. So this is kind of like this, okay, where the constant is between 0 and 1. So another things from here you can write is that n plus 1 minus an is less equals to q to the power n, and so this will be q to the power. So let me write it in terms of n plus 2 instead of n plus 1. So it will be much better to write easily. So this will be for each n greater equals to 1 instead of n equals to 2, and this will imply now q to the power n minus 1 modulus of a2 minus a1. So if you repeatedly use this n plus 1 minus an, so for example in the first part, like it will be a2 minus a1 less equals to q times a1 minus a0, then also again you can use for n plus 1 minus an, and then if you repeatedly use it, you will get n plus 1 minus an less equals to q to the power n minus 1 into a2 minus a1. Okay, so this is just by repetition. By repetition of the definition. Okay, so this is called a contractive sequence, and the fact is that every contractive real sequence is Cauchy. Okay, and in R, Cauchy sequences are convergent because R is a complete metric space with respect to usual metric, right? So we can say that contractive sequences are Cauchy and hence convergent. Okay, so now I'll write some properties about or test about the convergence. That will be useful to check like if some given sequence is like convergent or divergent. Okay, yeah, so this is convergent test. So these are like very important tests that are available in a textbook, and that you can use, like that you will be using at least throughout your life probably. Okay, so yeah, let me write the first test. Hi Binu, you can just turn off your camera. So the first test is comparison test. So just let me write the statement. Okay, then you can see the proofs of all of these tests in some standard textbook. Okay, so I'm not gonna doing the proofs here, so you can just follow any standard test textbook and then you can see the proofs. So the first is the comparison test. So it says that if 0 less equals to an less equals to bn, and eventually and summation of pn converges, then summation of an also converges. Okay, so eventually means it need not hold for every n, but after certain natural number this inequality should hold. Okay, so if 0 less equals to n less equals to bn holds after some certain natural number, then we can say that if summation bn converges, then summation a will also converge. Okay, and similarly if summation an diverges, so this will imply summation bn also diverges. Okay, so to remember this test, so the easiest way is if the largest sequence converges, like if the largest series converges on the right side, then left will converge. Okay, so if the left is like diverging, the smallest is diverging, then the bigger will also diverge. Okay, so this is a trick to remember. So this is for series mainly. So I think series was also covered, right? Because sequence and series are eventually same. A series is a sequence. Okay, you can see series as a sequence of partial sum, which is also a sequence. So I'm not gonna distinguish sequence and series differently, because just tests are different, but you can still like try to prove convergence and divergence. Okay, so I will be solving some questions, so don't worry about it. So the first another test is called ratio test. So let me just first write all of these definition, because this will be all useful when we'll be solving some questions. So this is called ratio test. So it said that suppose an is greater equals to 0 for all n, so this limit is L. Okay, so then we can say that if L is greater than 1, then summation of an diverges, and if L is less than 1, then summation an converges. Okay, so these are the, so this two is called actually ratio test. And so just remember, if L is greater than 1, then it will diverge, and if L is less than 1, then summation A will converge. But for L equals to 1, we cannot say anything. So I'll also give some examples when we'll be solving some questions, that why L equals to 1 test is inconclusive. Okay, so another test is called root test. So it says that if an is greater equals to 0 for all n, and a limit n tends to infinity, n power 1 by n is L. Then similarly, if L is greater than 1, summation an is divergent. If L is between 0 and 1, summation an is convergent. Okay, so this is called root test. And another important test is called integral test. So it says that if f is from 1 comma infinity to close 0 comma open 0 comma infinity is continuous and decreasing, okay, and an equals to f of n, then summation f of n converges if and only if this integration is finite. Okay, so integral test is very important. Okay, so there are a lot of series that you will not be able to solve or to show that the series is convergence or divergence using some regular test, but it will be far useful to use integral test than any other else. Okay, so integral test is really necessary, and I mean it's an important test actually. So another test, this is the last test I'm gonna write, is called Cauchy condensation test. Okay, so if n is greater than 0 for all n, and n is non-increasing, then summation an is convergent. So this will imply that summation 2 to the power n a of 2 to the power n convergent. Okay, so this is called Cauchy condensation test. So that means if summation a is convergent, then this is if and only if, then you multiply the sequence, I mean the subsequence, by a of 2 to the power n, and then you multiply by 2 to the power n, and then the sum will also converges. Okay, so this is if and only if condition. So n has to be decreasing, has to be positive, then summation converges if and only if you take the subsequence of a of 2 to the power n, and then you also multiply by 2 to the power n. Okay, so I hope these tests are all clear, I mean at least the definition and the statements. So you can see all the proof in some standard textbook. Okay, so since we do not have time, so we're not gonna go on to that. So let's start solving questions. Okay, so the first question is which of the following statement is true? So the first option is every sequence of real number has a convergent subsequence? So this is the first option. Second option is every sequence of real number has a monotone subsequence. Monotone subsequence. Third option is every bounded sequence of real number is convergent. The fourth option is none of the following above. Okay, so is this question clear to everyone? Like, are you guys able to understand? So my handwriting is a little bit bad, but I hope you all will be able to understand at least. So now give a minute to yourself and try to see that you are able to solve this question or not. So probably we have already given some statement in the beginning, so from there you can just give the answer. But yeah, if you have some counter examples for the other options, I'd be happy to listen. So yeah, Divyalocan, do you have any answer? What about others? Ranjit? So Ranjit was giving a lot of answers in the last class, and he was doing good in the last class. Yeah, Ranjit, do you have an answer? Can you hear me? So if you don't want
First
to,
one is correct.
last one is correct.
First one is correct.
Are you sure first one is correct? I mean, every sequence of real number.
It's the second one. Second one is correct.
Yes, the second one should be correct, right? Not every sequence has a convergent subsequence. This is true only when the sequence is bounded. Correct? So that is called the Bolzano-Weierstrass theorem. That's okay, Ranjit. It was a good try. Okay. So if a sequence is bounded, then it will have a convergent subsequence. Correct? But the sequence, like for example, you can take xn equals to n, and it doesn't have a convergent subsequence, right? So the first one is false. So what about the option third? Like, is it true or false? Like, if it is false, then you have to give me a counter example.
False.
It is false, right?
-1 for n.
Correct. So third is also 4. You can just take this example. Correct. -1 power n is a bounded sequence, but it has two limit points, right? 1 and -1. So that means the limit is not unique, so the sequence is divergent. So only the second option is true. So this is actually a very nice proof. You can see. I mean, if you, for example, if you open the SK Mappa book, I mean, you can just see the proof. So I'll encourage to everyone, please see the proof of option 2, the statement 2, Okay, at least today, otherwise you guys can forget. So yeah, I mean, I'm not gonna writing any solution right now, so option 2 is correct. Okay, so let us go to the next question, which is question number 2. So the question is, which of the following is a subsequence of cos of 1 divided by n? So the first option is cos of 1 divided by sin n. Second option is cos of 1 divided by square root of n. Third option is cos of 1 by 2 to the power n. And fourth option is none of the following above. Okay, so remember, I'll be using two sign always, either the curly bracket or the first order bracket for defining a sequence. Okay, so both are fine. So this is also a sequence, this is also a sequence. Okay, so has anybody replied? Ranjit says option 3 is correct, but then you have to tell me why other options are false. I mean, especially 1 and 2. Ranjit, can you tell me why option 1 and 2 are false? I mean, what sort of definitions are violating here? The definition of subsequence. Others are irrational, not natural. Yes, that is true. That is indeed true. So subsequence means the terms should be the corresponding terms from the sequence, right? So correct. But square root of n, sine of n, this can be other than the natural number n, right? So solution. Correct. So let xm equals to cos of 1 by m, right? So as subsequence, let's say xm of n of xn, or a subsequence of xn must have the form x of mn, right? Where mn is strictly increasing. Correct. So that means m1 less than m2 less than m3 and so on. Correct. For example, you can take x of 2n, x of 3n, x of n square, x of n cube. So all should be that m of n should be, which is a function of n, should be strictly increasing. You cannot take x of minus 1 to the power n, or let's say you cannot take x of mn where mn is 1 when n is even, or 2 when n is odd. So you cannot choose the second term, for example, if you take m1 to be the first term, then the second term should be always greater than the first term. Okay, so if you choose m1, m2 should be strictly than m1. So if you choose the first term and then if you choose the second term, you cannot come to the first term again. You have to either go to third term or any other term afterwards. Okay, so now let's come to the options. So in the first option you can see that cos of 1 by sin n is never equal to the cos of 1 by n, in the sense that if you take a subsequence, the terms will not be equal, right? Because sin n may not be equal to 1 by n. For example, you can take let's say the sequence cos of, like, you take the first term n equals to 1, then cos of 1 by sin 1 is never equals to cos of 1. So the first option is false, right? Similarly, you can take n equals to 2, then cos of 1 by square root of 2 is never equals to cos of 1 by 2, right? So the terms of the subsequence should be a term of the main sequence. Correct? So this is false. So if n was like square root of, like, if n was k square, then 1 by square root of n would be 1 by just k. So in that case, I mean, this cos of 1 by k would have been a subsequence of cos of 1 by n. Okay, so suppose if n was k square, then option second was true. Okay, so I hope you guys are getting it, because in that case square root of n will be just k, right? So then cos of 1 by k will be a subsequence of cos of 1 by n. Okay, so option second for now is false. So the only choice is cos of 1 by 2 to the power n, and those terms will be equal corresponding to the cos of 1 by n's. Okay, is it clear to everyone? For example, if you put n equals to 1, then cos of 1 by 2 to the power n will be cos of 1 by 2, which will be equals to cos of 1 by 2 for n equals to 2. Similarly, you can put n equals to 2, so it will be cos of 1 by 2 square, which is cos of 1 by 4. Correct? So that will be equals to the term n equals to 2 square, which is cos of 1 by 4. So that means the terms of the subsequence is a subset of the main sequence. So this option is true. Is it clear to everyone? This is the last reminder. Otherwise, we will move to the next question. You have to just see the terms of the subsequence, and the subsequence, the index of the subsequence would be strictly increasing. So these two things should follow always. If it doesn't follow, then it is not a subsequence. Okay, so I hope everybody has got it. So see, if you just don't want to speak, you can just write in the chat, okay, and otherwise you can just put a thumbs up. So there are a lot of emojis here, so that's, I can understand that you guys have got it. So let's move to the next question, which is question number 3. So question number 3 says that let un be a sequence of positive real numbers such that u of 2n minus 1 and u of 2n are convergent. So CGT stands for convergent. Okay, then so the options are un is convergent, second option is un is unbounded, option is even is a monotone sequence. And fourth option is none of the following above. Okay, is this question clear? So just give it a go, just try for 1 minute, and then let me know what are your thoughts. Option 4, really? I don't know the answer. Yeah, maybe we don't know. Why you are saying option 4 is correct, Ranjit? Minus 1 power n disproves.
Minus 1 power n is minus 1 power n is not convergent. Also, minus 1 power n is bounded. Minus 1 power n is not monotonic. The example due to.
Yes. So that means like you are oscillating, right, between odd and even.
Yes.
So that is the correct idea. So that means to construct and counter example in this case, you have to oscillate between odd and even, because they are asking specifically for u2n minus 1 and u2n. So in the first case, u2n minus 1 is a odd subsequence and u2n is a even subsequence, right? So as Ranjit said, you can take this counter example. And minus 1 when n is odd. Correct. And then this example is acting as a counter example for all the three options, right? Because even is not convergent, it has two limit points which are distinct. Even is bounded because all terms are less equals to 1, and of course even is not monotone because it's oscillating between 1 and minus 1. Correct. So all the options are false except the last option, which is none of the following above. So I mean, you can take others example as well. For example, you define a sequence like this. So let's say it's 1 by 2 when n is even, and let's take 1 when n is odd. Or you can just swap even and odd for 1 and 1 by 2. So this is also an example which says that none of the three options is true. Correct? Is this clear to everyone? What about others? Kanu Nayak, Divyalochan? I think he didn't reply anything today. And what about others? Shruti? What are the other names? Piyush? Are you guys getting it? Binu? Are you guys following up with me? Do you have any doubt? I mean, you can ask me. This is like one time opportunity, and you will not be able to ask questions in the next class, at least from these topics. Okay, so if you have any doubts, you can always ask me questions. It can be irrelevant as well. At least it should be from the topics, not like from it should not be other than real analysis at least. Okay, so yeah, I assume everybody has got it. And on that note, I'll go to the next question, which is question number 4. So let me see which question is there. Okay, so let me write this question. If a sequence uh, an oscillates finitely and Bn is a sequence of positive numbers such that limit Bn is 0, then A and Bn so the first option is a divergent sequence. Second option is an oscillatory sequence. Third option is a null sequence. Fourth option is may not converge. Okay, so yeah, anyone tell me? Option 3. Yeah, I mean, Anindo, can you tell me what is the definition of a null sequence? Like, what do you mean by a null sequence?
Null sequence means it converges to 0.
Oh yeah, yes, that's true.
So as n oscillates finitely, so n is bounded. As Bn tends to 0, so n Bn must tends to 0.
How do you say that? What is the proof of that?
Well, n minus, I mean, let's say mod n less than k, then mod n Bn minus 0 is mod n Bn. Then it is, if I take Bn as epsilon by k, as Bn tends to 0, so I can take Bn as small as possible. Then epsilon by k into k, it would be less than epsilon.
Yes, I mean,
When I am taking mod of n Bn minus 0, it's actually mod n Bn, right? So after that, for given any epsilon, if I took as Bn tends to 0, if I took some delta such that mod Bn or some n0 such that mod Bn less than epsilon by k,
okay.
then mod n Bn is epsilon by k into k equals to less than epsilon, where k is the bound of An, of course.
Yeah, I mean, you don't need to necessarily take modulus of Bn because Bn is positive, so you can just take like simple Bn, right? So the proof is correct actually. Yeah, I mean, so let me write the proof for the others who didn't have get it. So a sequence which is oscillating finitely means the sequence is bounded. Okay, and a null sequence means a sequence which converges to 0. Okay, so since An is oscillating finitely, An must be bounded. Okay, So this implies there exists m greater than 0 such that modulus of an is less equals to m for all n, right? Now you see that bn converges to 0, correct? So that means given epsilon greater than 0, you can find a natural number k such that bn is less than epsilon for all n greater equals to k, right? So here we will be taking the epsilon as epsilon divided by m. So let's say this is our epsilon. Okay, so the left side epsilon is a function of epsilon, or maybe you can just take epsilon 1. There exists a natural number k such that modulus of bn is less than epsilon 1 for all n greater equals to k, and this is same as bn less than epsilon 1 for all n greater equals to k. So this is because bn is positive, so it doesn't matter if you put modulus or not. So now you try to see that a and bn is same as modulus of an into modulus of bn. So this will be less equals to m times bn, right? Because modulus of bn is bn, and this is less than epsilon 1 into m. And you can see that epsilon 1 into m is just epsilon. And this is true for each n greater equals to k. Correct? So that means given epsilon greater than 0, we are able to show that the modulus of a and bn is less than epsilon. Correct? So this is implying limit n tends to infinity, a and bn is 0. Is this clear to everyone now? So please go through the proof for a minute, and if you cannot understand, just tell me right now, okay? Then I'll explain it again. And if you don't want to speak up, you can just put it in the chat. So write your question in the chat. I'll explain again. So Ranjit said clear. So yeah, I hope he has understood. What about other people? Shruti, Kanhu, Divya Lochan. Yeah, Divya Lochan said yes. So that means he has understood. Okay, fine. So that means option 3 is correct. First is false because it's a convergent sequence, it's not divergent. Second is also false because it's not a oscillatory sequence. So option third is true. Okay. So then let me go to the next question, which is question number 5. So let me see some good question. So this is the first option. So n is a harmonic series which is 1 plus 1 by 2 up to 1 by n. Then first option is A is convergent and converges to 101. N is divergent. Third option is An is bounded. Fourth option is none of the following above. So now tell me what is the answer of this question. So yeah, you guys can try for a minute and then let me know, like, what do you guys think. So this is very important question. Okay, so you should understand why this series is important.
So limit n tending to infinity a, that is the NP series with p equals to 1, right? So it is divergent then.
I mean, why the NP series for p equals to 1 is divergent then?
Well, we can rearrange it as 1 plus half plus 1 by 3 is less than half, half plus half, that is again 1, then 5, 6, 7, 8.
What do you mean by
That
less
is
than?
also 1.
I don't think it should be less than. By less than you cannot prove the sequence is convergent, right?
Oh, sorry, divergent. Divergence means I need to be greater than, yes. So it would be then 1 by 3 plus 1 by 4 is greater than 1 by 4 plus 1 by 4, that is half. Then 1 by 5 to 1 by 8, that is also greater than 4 into 1 by 8, that is half. And it would be like 1 plus half n into half. So it would be tends to infinity as n tending to.
So which will be greater than 1 by 1 plus n by 2? I mean, what
I am rearranging like this 1 plus half plus.
I have understood. Yeah, I have understood. Like, you are grouping the terms and like trying to put that those terms are greater than 1 by 2. But I'm asking which subsequence will be greater than 1 plus n by 2. Can you tell me the subsequence?
Oh, which subsequence would be greater than 1 by, yes, that would be for 1 by 2 to the power n. Right.
Is it 1 by 2 to the power n or simply 2 to the power n?
Sorry, I mean a 2 to the power n. Yes.
Yeah, so it will be a of 2 to the power n, right?
A of 2 to the power n. Yes.
Yeah, that is true then. Yeah. So that means you prove that subsequence is diverging, right? So that means the whole sequence will diverge. That means the sequence is unbounded above. Correct? So what about others? So any thoughts you guys can like discuss with me? Yeah, Divya Lochan, do you know the trick to solve this question? So I think in the beginning of the week 1, I had discussed that how can you show a sequence diverges, or what are the things to show a sequence converges, because sometimes it can be easier to prove a sequence is divergent because there are a lot of criterias to show a sequence is divergent, because if you can find out one subsequence that is divergent, the whole sequence will diverge, right? So should I write the proof? What about others? Ranjit, what about you? Do you know the trick, or so? Yeah, let me go through the proof shortly, so I'll not be explaining all the terms. So try to see that we're gonna construct a subsequence from an that will diverge to infinity. Okay, so first see that a2 is 1 plus 1 by 2, correct? What about a4? a4 is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Is this clear first of all to everyone? Because this can be confusing how the terms are coming from an, right? So in general you have seen that an is a single terms, right? Like n or n square or 1 by n, but it is like a sum of sequence here. So if you just put n equals to 1, this is just a1, which will be just 1. If you put n equals to 2, then it is 1 plus 1 by 2, right? Similarly for a4 and so on. So now see that this is greater than 1 plus 1 by 2, just keep it as it is, and this is 1 by 4 plus 1 by 4, because 1 by 3 is greater than 1 by 4, correct? So this is 1 plus 1 by 2, and this is again 1 plus 1 by 2. So the sum will be 1 plus 2 by 2, correct? So let me show for another term, which is a8. So this will be again 1 plus 1 by 2, and already we have shown that for 1 plus 1 by 3 plus 1 by 4 it is greater than 1 by 2. So let me write it greater than 1 by 2, and then it will be from 1 by 5, 1 by 6, 1 by 7 and 1 by 8, correct? Because already we have proved that a4 is greater than 1 plus 2 by 2, or simply we can just use 1 plus 2 by 2. Because already we have proved the first 4 term is greater than 1 plus 2 by 2. So now see that the last 4 terms, the tail of the sequence here for a8, that is 1 by 5, 1 by 6, 1 by 7 and 1 by 8, this will be again greater than 1 plus 2 by 2 plus 1 by 8 plus 1 by 8 plus 1 by 8, because 1 by 5 is greater than 1 by 8, 1 by 6 is greater than 1 by 8 and 1 by 7 is also greater than 1 by 8. So that means a8 is greater than 1 plus 1 by 2, this is 2 by 2 plus 1 by 2. So this is 1 plus 3 by 2, correct? So now you see that we have shown a power 2 to the power 1 is 1 plus 1 by 2, a of 2 square is greater than 1 plus 2 by 2, and a of 2 power 3 is 1 plus 3 by 2. And similarly you can show a of 2 power n is 1 plus n by 2 by induction. So you can just simply use induction, then you will be able to show that this is greater than 1 plus n by 2 for each n greater equals to 1, correct? Now clearly the sequence diverges, correct? A of 2 to the power n strictly greater than order of 1 by n, order of n. So if a sequence is greater equals to order of n, the sequence can never converge. So that means a over to the power n is diverging to infinity. Hence an is also tending to infinity. So is this clear to everyone? what we just did. Is it clear to everyone? Ranjit, did you understand? Kanu, Divyalochun?
Yeah, yeah.
Okay, what about Piyush Jain? Okay, so we can say that n is divergent.
One question.
Yeah, sure.
Each term we get a 1 by 2, 1 by 2, and get a frequent series is 1 plus 1 by 2, 1 by 2 is greater than 1 plus 1 by 2, 1 by 2, etc. n times.
Yes.
And then that method is wrong or right?
I mean, which, like, I don't understand your question. So you're saying the sequence is convergent or divergent?
Yes, this is divergent. My question is each term 1 by 2, next 1 by 3 is replaced by 1 by 2. That is greater than 1 plus 1 by 2. Each term will be 1 by 2, 1 by 2, 1 by 2.
Yeah, each term will be greater than 1 plus 1 n by 2. I mean, each n 2 to the power nth term. So actually what is happening is, as n grows to infinity, you can reach every single real number. So that means that you cannot bound the number an. So you might think from here that, uh, like for example, you give me a number, let's say 1000. So you can tell me, just show me how you reach the uh, number 1000, right? If a sequence is unbounded, or if a sequence is like diverging in infinity, it should cross every possible real number that is exists, correct? But here you see that as n grows, you can do that sum, 1 plus 2, 1 plus 2, 1 plus 2. So 3 will 3 by 2, 4 by 2, 5 by 2, and at some point you will be reaching to 2000 by 2, correct? So that means that will be 1 plus 1000. So that means afterwards all the terms will be greater than 1000, correct? So you are crossing every single real numbers in the real number system, so the sequence diverges. I hope you understood, Ranjit, right?
Yes, yes.
Okay, thanks. So yeah, let me go to other questions. uh, Let me find out some interesting questions. Wait, just a minute. There are lots of questions, but this like all are similar kind of questions. uh, just a minute. Uh, so I think I solved some questions from box function in the second or third class. So let us see some question from box function, that is sequence of box function. So let me see the question I had before. Sin n pi by 2. This is n 2x. Yeah, I've got the question now. So yeah, let me go to question number 6. So define Qn equals to box function 10 to the power n square root of 2 divided by 10 to the power n. Then Qn is convergent and converges to 10 root 2. Qn is divergent. Qn is convergent and converges to root 2 by 10. Qn is convergent and converges to root 2. So I had explained the box function in week 2 classes, week 2 discussions, and I hope I had solved some question there. So I'll not be explaining again the definition of box function. I'll just give the basic definition. So you can see the week 2 lecture where I have discussed like a lot of questions and the graphical presentation of box function, which is the staircase function. I mean, which looks like stair, and also by using that I had solved that the set of rational number is dense and which is also not closed. So please go to week 2 classes later. Okay. So now solve this question. So Qn is 10 to the power n square root of 2 box function of, and then divide by 10 to the power n, and then you have to find out if Qn is convergent, and if so, then what is the limit, or otherwise Qn is divergent or not. Aninder, do you have an opinion? Aninder, Ranjit, Divyalochan. Option 4, why? Can you tell me why?
Yes, because box 10 root 2
Mm-hmm.
for any x, box x is from x minus 1 to x, right? Between so it would be x minus 1. So box 10 to the power n root 2. It is 10 to the power n root 2 minus 1 less than equal to 10 to the power n root 2 less than equal to 10 to the power n root 2, right? Hello?
Yes, tell me.
Can I ask?
I'm listening to you.
Yes,
I'm all my ears. Yeah, tell me.
yes, I'm saying that box s is always in between x minus 1 to a.
Why is that true?
So, yes, I mean, when I'm saying between, I'm taking inclusive of x minus 1 and x also.
No. That's okay. I understand. But I'm asking why is it true that box function is between x minus 1 and x? How do you get that?
It is the floor function, right? If I'm taking the integer part, then it must be the difference from x must be less than
Because
1.
you are telling me the second definition of box function which relates to x. That comes from the first definition. I mean, that's why I'm asking the question, how do you get x minus 1 less equals to box x less equals to s? Because in general, there's the other definition which comes naturally, right? Because you are directly starting from x minus 1 less equals to box x less equals to x. I mean, just asking, how do you get there?
Oh, okay. Maybe from Archimedean property.
I mean, can you elaborate more, please?
Okay. That's minus.
Okay, yeah. Adar also can try to solve this question, please. I think
Yes.
option 4 is true. I think you replied option 4, right? This is a true option.
Yes. I actually saw that as the first one is if I took 10 to the power n root 2 minus 1 less than equal to 10 to the box 10 to the power n root 2 less than equal to 10 to the power n root 2,
Okay.
and I divide all 3 by 10 to the power n, then the left side is root 2 minus 1 by 10 to the power n, and right side is only root 2. So if I took the limit, the left side and right side both tends to root 2. So by sandwich theorem, I can say that Qn tends to root 2.
Yeah, that is true.
But when I am saying that for any x, box x is in between x minus 1 to x.
Yeah, that is why I'm
Okay, so
asking how do you get that?
uh, so uh, it's kind of like my intuition, because I'm just removing the fractional part, right? And the fractional part is always less than 1.
Why
So
fractional part is always less than 1?
yes, the fractional part is always less than 1, because
How do you
the
connect
fractional
how
part,
do you connect fractional part with box function?
because by removing the fractional part, I actually what do we say when we say box x? The box x is the greatest integer not greater than x, right?
Uh,
So
yes.
so when I am saying the greatest integer, that means I am terminating the fractional part, because if I took the fractional part is always less than 1, because we took the 10 as the denominator, right? So if the fractional part is 0.52 or something, a1 into a3, so when I am saying point a1 into a3, it does
Mhm.
mean that a1 by 10 plus a2 by 10 square plus a3 by 10 cube, dot 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 dot. So it is, as a1 into a3 are digits, they are always from 0 to 9, so they are actually less than 10, and that's why the fractional part is always less than 1.
Yes, that is a good proof. Yeah. But now you come to the question why you said that box x between x minus 1 and x. So that means fractional part of x is x minus box x, right?
Yes.
Yeah. Then how do you get that?
And from that, I can say that fractional part is less than equal to 0, like greater equal to 0, less than 1,
Yeah,
less
yeah,
than
that
equal
is
to
true.
1.
That is true. Yes.
So, so x minus box x is greater than 0 and less than 1. So from that, uh, by subtracting the x, and after that reorienting the uh, sign of less than, actually, because
No, actually, that's why I asked you the question, right? So if you what you are saying, from there you will only get box x less than x less equals to box x plus 1, and from there you will be getting what you have assumed, right? So that's why I ask you question, how do you get the second inequality? You are going to the correct direction. So if x minus box x is between 0 and 1, then you're gonna get box x less than x less equals to box x plus 1, and from there you can show that x minus 1 less than box x less equals to x. So,
yes.
so yeah, the first definition was enough to prove, and indeed you can use the second definition as well. But yeah, all are equivalent. So I asked the question because you started from the second definition, which coming from the first definition. Yeah, I'll explain for the other viewers, for the other participants. So, Rajit, do you have an answer, or should I start solving the question? Okay. So yeah, let me explain what I just said. So, in general, so So I had given a simple proof, I think in the week 2 class probably, so that x is always like box function of x is always less equals to x less equals to box x plus 1. Okay, this is true for any x in R. This is because box x is the leftmost integer, so that means x will be always lying on the right side, correct? And similarly, if you take box x plus 1, then box x plus 1 will be the rightmost integer, which is always less than x, I mean greater equals to x. So that's how this inequality comes. So this is the very first basic inequality of box function which connects with x, and from here you can derive what Anita just said. So from here you can just derive that x minus 1 less equals to box x less equals to x. Okay, so it is easy to derive from here, because if you use the second part, which is x less equals to box x plus 1, you will be getting box x is less greater equals to x minus 1, and already box x is less equals to x, right? So these two are equivalent. So now let's come to the question. So Qn was given box function of 10 to the power n root 2 divided by 10 to the power n. So you start from 10 to the power n root 2, which will be less equals to 10 to the power n root 2 less equals to box function of 10 to the power n root 2 plus 1, correct? So now to get q of n, you have to divide by 10 to the power n, right? Then only you will get q of n, and 10 to the power n is positive for all n, so this will be box function of 10 to the power n root 2 divide by 10 to the power n less equals to 10 to the power n root 2 divided by 10 to the power n, and this will be also 10 to the power n square root of 2 divided by 10 to the power n plus 1 by 10 to the power n, correct? So this will imply qn less equals to square root of 2 less equals to qn plus 10 to the power minus n, right? Is it okay? So this will imply root 2 minus qn is greater equals to 0 and less equals to 10 to the power minus n. And then you can just take sandwich theorem, which is also called the squeeze theorem or mousetrap principle. And then the left side limit is 0, the right side limit is 0, so the middle limit will be 0, or therefore by squeeze theorem limit of square root of 2 minus qn is 0. So this will imply limit of qn is square root of 2. This is a very important question, okay, which, like, if you are preparing for IIT JAM, NET exam or GATE exam or whatever, like if you're trying to get into PhD, so this sort of questions they ask, especially in TFR also, like the question will not be the same, but the trick will be same. So they will somehow modify the sequence in such a way that you can use this either two inequalities and then you will get the answer. So basically you have to like be clever to apply this inequality and get the proof. Okay, so this is a very nice question actually. So let me put double star or maybe 3 star for this question. Okay, so option 4 is correct, all other options are false. So is this clear to everyone? Is this clear to everyone? Piyush, Divyalochan, Kanu, Ranjit, if you have any doubts, just ask me right now. Then I'll be explaining it, or then I have to move to the next question otherwise. Okay, so yeah, everybody has understood it seems. So then let us move to the next question, which is question number 7. So let me write in the next page. Oh, okay. So what should be the next question? So next question is also very good. Okay, I personally like this question also. So let an be a sequence such that limit of an plus 1 minus an is 0. The modulus of limit of an plus 1 minus an is 0. Okay, then an is Cauchy, an so let me write like this: an is always Cauchy, an is always divergent, an is always bounded, or let's say unbounded. So let me write the fourth option, which is yeah, an can be divergent or convergent. Yes, or maybe just convergent. Yeah. So is this question clear to everyone? So n is a sequence given by a condition which is modulus of n plus 1 minus n is 0. Then it asks for 4 options, that n is always Cauchy, n is always divergent, n is always unbounded, n can be divergent.
যদি আমি এ করি
Yeah, tell me. but I don't think Ranjit, I don't think that option give you a correct answer. So which option are you trying to define? Because for your example, the limit of an plus 1 minus an may not be 0. Okay, so try with other examples, because for your example you see that that limit can be 2 also, right? Or sorry 8 also, because you have taken 4 times, something like that. So yeah, it can be 8 also. For example, you take the even sequence, right? So if you take n to be let's say 2n minus 1, then the limit will be 8, correct? Then the condition does not hold. So you guys give it a try. I'm just coming within 2 minutes. Okay. Yeah, tell me if you guys have any answer. N equals to 1 by n. Okay, but then I mean, then which option is true?
Actually, the notations are not allowed here. I am trying to say that an equals to summation 1 by I equals to 1 to n. That means 1 plus half plus dot 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 plus 1 by n.
Yeah, I mean, then I mean, like what you're trying to say? The option is good, obviously.
Actually, then we saw that n is divergent and also n satisfying this limit criteria, right?
Hmm. Any simple examples you know, rather than this harmonic series?
Actually, actually, this one just we just used some minutes ago. That's why it came to me.
Ranjit,
Uh,
minus 1 to the power 1 by n, minus 1 to the power n does not work because it does not satisfy the limit condition. Option 4 is true, of course, but the example you are giving doesn't justify the option 4. So you see that the limit condition is not satisfying for all n, right? If you take yn to be an plus 1 minus an, then yn will have two limit points. One is 0, another is 2 for your sequence. So as Anindo said, uh, you can take the harmonic series as a counter example.
I'm taking minus 1 power n plus 1 minus 1 power n, taking minus 1 power n, taking outside, and 1 minus 1 goes to 0.
Are you sure?
One.
I don't think this is true.
Oh,
So you take yn to be an plus 1 minus an, okay, and you do, then you try to find out the subsequence of yn. So there will be two subsequences, the two relevant
it's 1
subsequence.
minus 1.
Yeah, so
1 minus 1.
yeah, you are getting 0 and 2, right? The limit. Okay, so
No,
yeah,
the limit would be always 2 actually, because an plus 1 minus an will be always 2 for minus 1
My
to
doubt, my question is the an plus 1 and odd term and the, I think, next term, the
yeah, the limit
first
will
term
be,
and second term, first term, second term and third term, fourth term, alternatively subtract that.
the,
Each
li-
term will be
the
2.
limit will be always 2, I think, right?
Okay.
Yeah, so because you said you are taking common of minus 1 power n, so then it will be minus of 1, which will be 2, and minus 1 power n, if you take modulus outside, it will be 1. I told you 0 because if you try to see for n even n odd, because that is the simplest thing to understand in the beginning.
Okay.
Okay, so let me show you your example first. So you tried to take this example. So then n plus 1 minus an would be this one, right? Correct. So you can take modulus of minus 1 power n outside. This will be minus 1 and this will be minus of 1. So this is just 2. Correct. So the limit will be always 2.
Okay.
Yeah. So limit condition does not satisfy, right? So first option you have to discard. So let us take a simple example. So as Anindo has said, you can take the harmonic series, which is 1 plus 1 by 2 up to 1 by n, but I will be taking more simple examples. So I will be taking just square root of n. Okay. So then you can see that limit n tends to infinity, an plus 1 minus an is 0. So indeed you will get this, and this is same as 1 divided by, I mean you can just do the conjugation instead of doing directly. So this will be this, and n plus 1 minus n divided by square root of n plus 1 plus square root of n. So this is just 1 divided by square root of n plus 1 plus square root of n. Correct? And this limit is 0, right? This limit is 0, right? So that means the limit condition holds, but the an is divergent sequence. So the first option is false. Correct? What about second and third? So you can just take a constant sequence. Correct, you can take just constant sequence. So for option 3 and 4, I mean sorry, option 2 and 3, take an equals to 1 for all n. So then you can see that an plus 1 minus an is 0, because an is a constant sequence. So that means an is divergent. I mean, n is not divergent because n was a constant sequence, and also n is not always unbounded because convergent sequences are bounded, right? So this counter example or this example shows that option 2 and 3 are false. And by example 1, which we just showed, for an equals to square root of n, option 4 is true. Is it clear to everyone? We have given two counter example. One is square root of n, another is just constant sequence. You can take any constant sequence. There are tons of examples, so you can take an equals to log n as well. Okay, so this will also tell you that modulus of n plus 1 minus an limit is 0. But log n is not convergent, right? You can take harmonic series as well. Okay, there are lots of examples. You can take this example as well. So there are a lot of examples you can take. You can take log of n plus 1, log of 2 to the power n, or so on. So yeah, I mean, is this clear to everyone? Divya Lochan, are you getting it? You are not replying much today. Aninda said great example. Yeah, thank you so much. So these are simple example, right? You don't need to go for complicated examples. Yeah, I mean, is this clear to everyone? Otherwise, I'll continue this question and then I'll give another question, which is subsequent part of this question 7. Any doubt? Kanu, Divya Lochan? Binu? Okay, so I'll go to the next question then. So this is question number 8, right? Yeah. So let an be a sequence such that modulus of n plus 1 minus an is less equals to 1 by 2 to the power n. Then n is Cauchy. Second is n is divergent. N is convergent. This is n can be convergent or divergent. N is so n can be divergent and n is always divergent. Okay. So a sequence an is given such that modulus of an plus 1 minus an is less equals to 1 divided by 2 power n. Then the first option is an is Cauchy. The second option is n can be divergent. Third option is n can be divergent or convergent. And fourth option is always divergent. So yeah, so give it a try, and I'll be coming within 2 minutes. Okay, just try for 2 minutes maximum. Yeah, anyone? Any answer? Aninda, Ranjit, Kanu, Devalochan, Parshuram, Binu.
If we take am minus an, let's say m greater than n, then am minus an is less than am less than equal to am minus 1 plus mod of am minus 1 minus am minus 2 plus dot 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 plus an plus 1 minus an modulus.
Okay.
After that, we can say that
AM plus 1, not, it will be AM minus 1, right?
yes, I'm saying am minus an, it
It,
will be less than equal to mod of am minus 1 plus mod of am minus 1 minus am minus 2 plus dot 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 plus mod of an plus 1 minus an.
yes, yes, yes.
Then it would be 1 by I mean, I am not calculating anywhere. I am just calculating in my mind that if this is somehow can be like one, if we took common 1 by 2 to the power n, then the portion in the bracket, it would be a finite subsequence of the summation 1 by 2 to the power n.
Okay.
So as the 1 by 2 to the power n is convergent, so we can make it Cauchy. So maybe n is Cauchy is the correct answer.
How do you make it Cauchy on the from the right side? You said. Okay, so you are saying you are like trying. I mean, like, are you doing in the?
I am on the right side. I am getting 1 by 2 to the power n common, and in the bracket I am getting a finite subsequence. If I am talking about m minus n where m and n are fixed, then I am getting where m is strictly greater than n, then I am getting on the right side 1 by 2 to the power n common, and in the brackets 1 plus
Okay.
So this is why I am saying that it is Cauchy.
Okay. So yeah, I mean you are
I am not
almost.
completely confident about my answer, but I think it
No,
is
no, it
Cauchy.
is correct. It is correct. It should be Cauchy, right? Yeah, I mean, like, you are getting to the correct answer, obviously. I mean, like, on the right side, you get 2 to the power n, geometric series, and then it will converge to 0, right? As m and n goes to 0. So,
Yes.
yeah, that's true. What about others? Is it true that n is Cauchy? So that means this is a nice question, right? So in the last question we saw that if the limit of subsequent terms is going to 0, n need not be Cauchy. But if the summation is finite, so you see from here that n plus 1 minus a n less equals to 1 by 2 to the power n, you can apply comparison test. So I just explained in the beginning, right, that in the comparison test, if the bigger sequence or bigger series converges, the left will converge. I mean, the smaller will converge. So from here you can say that summation a n plus 1 minus a n converges. Correct. So if in exams it comes like that, that if summation modulus of a n plus 1 minus a n converges, then a n still will be Cauchy. You don't need that a n plus 1 minus a n should be 1 by 2 to the power n less equals to. Okay. So this is a very nice question. That's why let me put it 2 star. So you see that to prove a sequence is Cauchy, we have to go through the basic definition, that is a minus a n is less than epsilon, where m is greater than 1, m is greater than n, and a minus n will be less than epsilon for m n greater equals to some natural number, right? For any epsilon greater than 0. So yeah, let us fix m greater than n. So let m greater than n. Correct. Then am minus an. So this will be an minus of an plus 1 plus n plus 1 minus of an plus 2 plus am minus 1 minus am. Correct? And by triangle inequality, this will be an minus an plus 1 and plus so on, like this, a minus 1 minus am. Correct? So now you already know that an plus 1 minus an is less equals to 1 power 2 to the power n, right? So this will be less equals to 1 by 2 to the power n plus 1 by 2 to the power n plus 1, and plus, now can anyone tell me how many terms are there? Anyone? This is a basic question, right? This is the 12th grade question. So what should be the last power? Anyone? How many terms are there here? So what should be the last term according to the definition of an plus 1 minus an less equals to 1 divided by 2 to the power n? Yeah, tell me, anyone. Ranjit, what will be the last term? What will be the last term? Please tell me. So there are, like, the first term is an, second term is an plus 1. So you just focus here. So this is the first term an. On the next absolute term, the second term will be an plus 1, and so on up to a minus 1. So it's going from n to m minus 1. Correct? So how many terms should be there? Okay. And then can anyone tell me what to do here? You can just take common of 1 power 2 to the power n, right? So this will be 1 plus 1 by 2 up to 1 divided by m minus n minus 1. Correct? So what is this sum on the right side? So this will be 1 minus 2 to the power m minus n divided by 1 minus 1 by 2. Correct? So this is just 1 by 2 to the power n 2 times 1 minus 1 by 2 power m minus n. Is this okay with everyone? Is this clear to everyone? So now you see that the right side goes to 0 as m and n grows, right? Because m is strictly greater than n. So this will go to 0 and this will also go to 0. Correct? So if the right side sequence goes to 0, you can make it less than epsilon. Because already we proved in the beginning, right? If bn tends to 0, you can make bn to be less than epsilon. So you can take this sequence to be bn for different m and n. Correct? And then you can take the maximum of those natural number. So from here we can say that n is a Cauchy sequence, right? 1 by 2 power n goes to 0, 1 by 2 power m minus n is goes to 0. Correct? Or if you want, you can make it more simplified. So this will be, so we started with m minus n. This is 1 by 2 power n. And this is what? This will be less than 2 because the negative term is less equals to 0. So this is 2 and this is 1 by 2 power n minus 1. Correct, because the negative term is less equals to 0. Here m is strictly greater than n. And the right side is goes to 0, right? This goes to 0. Correct? So, let me write it here. Therefore, n is a Cauchy sequence. Is it clear to everyone? How like we are getting this? You can simplify in the beginning, or you can just go to come to this definition: a minus a n less equals to 1 divided by 2n minus 2 to the power minus 1. Okay? This all same thing. So you can go for the proof up to this step where you are getting 1 divided by 2 to the power n minus 1. or you can just leave it here. So you can just leave it here. Okay, so it's up to you what you want. So yeah, I hope this is clear. And so n should be a Cauchy sequence. So n cannot be divergent because in real number system Cauchy sequence implies convergent because R is a complete space, correct? R is a complete order field. So this is false. An cannot be divergent. This is also false. And An is always divergent. This is also false. Correct? So I hope this is clear to everyone. Is there any doubt? Anyone? Divyalochan, Kanhu, Ranjit. Ranjit said yes. Parshuram, Behra, Binu. So the corollary is like this. Let me write it as a corollary. So if n is a sequence such that modulus of n plus 1 less than n is finite, then n is a Cauchy sequence. N is always a Cauchy sequence. Okay, so this is C. So is this clear? This is a corollary. This is more general case. So you don't necessarily need summation of like modulus of n plus 1 minus n less equals to 1 power 2 power n, 1 divided by 2 power n. So if the summation converges, that's more than enough. Similarly, you can do the proof. So if this is clear, then I think we are good to stop here for today at least, and then maybe we can meet in the next week. I think the next class will be on 30th of August, right? So is there any doubt? I'm asking for last time. Divyalochan, Ranjit, Aninda.
No doubt, sir.
Yeah, tell me, Ranjit.
The previous assignment question, the 1 minus